Welcome to this video lecture. Previously, we looked upon introduction about inertia, then what is dynamic force analysis. In the second video, we are looking upon the dynamic force analysis which is acting on the IC engine. So initially, as in the last video we discussed, the net piston load we are going to calculate, that is going to be FP. It is nothing but FL minus FI. What is this FL? FL is nothing but the load which is caused because of the gas pressure. Definitely if there is any resting body at rest, then it will be opposed by inertia force. So it is opposed by the inertia force. So what is going to be the net effective piston force or piston effort? It is nothing but load which is going to be given by the gas which is opposed by the inertia force. Now this effective piston force is going to be, since the piston is moving, is it not, is going to be travel to the crankshaft. How it is travel to the crankshaft? Through connecting rod. So we have to resolve this. This is going to be your FP. Since it is going to be resolved towards this FQ, and this is going to be your F1. What is this F1? F1 is nothing but the normal reaction. We know that is, if your body is moving along a plane surface, due to the force is going to be acting, there will be the resisting friction. Then there will be a reaction force acting on the body, and also there will be the weight acting on the body due to because of the gravitational force M into G. So this is the normal reaction. FP is going to be the horizontal force, F1 is going to be the vertical force, FQ is going to be the inclined force acting along the connecting rod. So this inclined force FQ is going to be traveled and it is passed to the crankshaft through crank. So now once again it is resolved as the force which is acting on the crankshaft or crankshaft bearing is FB. The force which is perpendicular to this is nothing but FT. This is the force acting on the crank pin. So crank pin effort. So FT is going to be called as the crank pin effort. This crank pin effort is the main important cause which is rotating the crank. Crank pin effort. Effort, it is putting its efforts. So it is rotating the crank. So torque equal to the torque which is generated by this crank is nothing but Ft into radius of the crank. Let's start deriving the forces one by one. Let mg is nothing but the mass of the reciprocating part. Multiply with the gravity, we are getting the weight of the reciprocating parts. AR is acceleration of the reciprocating parts, which I can able to get multiplying the omega into radius, crank radius. So here the inertia force is nothing but mass into acceleration, where the acceleration due to gravity is coming with respect to omega square or cos theta plus cos theta by n. So here a full formula for the inertia force is m omega square or cos theta plus cos 2 theta by n, where n equal to L by R. L is nothing but the length of the connecting rod, R is crank radius, where theta is nothing but the rotating angle of the crank angle otherwise. So we are going to derive the next force, that is going to be the force which is caused by the gas pressure, that is FL. So in single acting engine, FL is nothing but pi by 4 d square into pressure. Directly we can substitute. If it is going to be double acting, then we have to consider both the sides of the piston. This is the area where initially the gas explosion is acting. So pressure P1, here it is going to be pressure P2. So when it is double acting, we have to consider both the areas. Whenever we are considering like that, then here the pressure acting on the piston on this left hand side into area. This area A1 is nothing but pi by 4 d square. This one. So where d is nothing but the bore diameter of the cylinder, otherwise piston diameter. Now what is this A2. A2 is nothing but A1 minus A, where A is nothing but pi by 4 small d square, where d is the diameter of the piston rod. Okay, where d is nothing but the diameter of the piston rod. So what is going to be happen means, so here everywhere it is going to be the same area, so it is A1. Whenever it is going to be the other side of the piston, so there will be piston rod. So this area is going to be somewhat different. So this is the area occupied by the right hand side. So this area is subtracted from the previous area A1. So here the piston rod diameter is there. So you can able to calculate what is the piston rod area of cross section, pi by 4 d square. So you are substituting A1 minus A, so that we are getting this. What is the load acting on the right hand side is nothing but pressure on the right hand side into A1 minus A. So till now, some of the important points we have to remember. What are the piston effort? It is nothing but FP, which is the net effective effort that is caused by net load on the piston plus or minus inertia force. When we have to use inertia force, and minus means always in acceleration time it is minus, in deceleration time it is plus. If the friction is going to be included, then we have to subtract the frictional resistance. Why we are subtracting it? Because friction also acting against the movement of the piston. So the P, the net pressure of the steam or gas on the piston, if it is given, simply for single acting cylinder we can calculate FL like this, pressure into area. For double acting cylinder, the previous slide we calculated that pressure 1 into area 1 minus pressure 2 into A. Next thing is, for a vertical engines, very important, if the vertical engine is going to be considered, then the weight of the reciprocating parts plays very important role in acceleration. So whenever the piston is moving downwards, otherwise it is accelerating, at the time weight of the piston also helping the movement of the piston to come down. So it is going to be plus. Whenever the piston is moving up, then the weight of the reciprocating parts we have to take it as negative. So this important points we have to consider. Let me move on to the next one. So the next thing is, we are going to calculate FQ. So we calculated FB. Okay, we have to calculate F1 and FQ. Okay, so in that case, so remaining forces also we are going to be put it here. That is, this is going to be the F1 thrust on the sides of the cylinder walls, or normal reaction with the gate bar. Then FB, the thrust on the crankshaft bearing. Okay, so the last one is crank pin effort. Now, how to calculate this FQ? Let me consider this triangle. Okay, you can see this triangle, I think so. This is the triangle. So using the triangle, you can go for the cos pi and sin phi cosines formula. So in that case, it is nothing but the pi, which is opposite side. Okay, opposite side is F1, adjacent side is FQ. So you can take it. Okay, similarly cos pi, adjacent side is FP, and then the opposite side is FQ. So using this cos pi formula, adjacent side is FP, hypotenuse side is FQ. So cos pi formula we can get what is FQ. So when I know net piston effort, then I can able to calculate FQ as well as the F1. So F1 is nothing but sin phi equal to F1 divided by FQ. So from that it came. Very important thing is another important one. So we have to look upon how to calculate pi, because in most of the cases the theta crank angle will be given to you. So we have to look up it as a two triangles. So one of the triangle is on the left hand side, then another triangle is on the right hand side. So for both this triangle, this length CQ is common. So what is CQ? When I am considering this, the CQ on the left hand side, it is nothing but sine pi equal to, since it is going to be opposite side, CQ divided by L. Here it is L, hypotenuse side. Similarly, when I am considering the right hand side, sine theta equal to, once again, CQ divided by R. So where CQ is common for in the both the formulas, L sin phi equal to R sin phi. So because of that, we are getting that N equal to L by R. Okay. So very important, we have come to the last stage of this force analysis on the IC engine. So in that case, we already completed the derivation of this FQ and Fn. So if I know FQ, I have to calculate what is FB, and the last one, it is going to be the FT. So FT is nothing but the perpendicular force, okay, so that is very, very important. So now we take the very important triangle relationship. So this triangle relationship we take. Okay. So this triangle relationship we take. Okay, so in this is the FT. Here it is going to be perpendicular. Okay, now it is going to be perpendicular. Hypotenuse is nothing but this side. Okay, FB is here. Okay, so what I want to know is, in that case, so this is FT, perpendicular line, this is FB. So I want to know what is this angle. What is this angle? Actually, in the diagram it is represented as theta plus phi. If this is theta plus phi, this is also theta plus phi. Actually, we are calculated this, then we have to moving on to this. That's how it is coming to picture. Now let's see this one, this triangle on this side. So this triangle, when you take this triangle, what is going to be happen means this is 90, so 90 minus theta. So when you take the full triangle, okay, we have to take this full triangle. Okay, this is 90, this is pi, so this is 90 minus pi. Okay, now come to this point. Okay, this purple color triangle, no, that is CMO. It is the overall angle degree is 180 degree, minus of the known thing is 90, minus of minus plus, so another minus 90 plus pi. So 180 degree, 90 will cancelled. So at last we are having the angle, okay, MCO is theta plus phi. Since this is theta plus phi, this is also going to be theta plus phi. Okay, so now theta plus phi, how it is came, we come to the picture. We go to the derivation. Okay, sine theta plus phi. What is the sine theta plus phi? It is nothing but the opposite side by hypotenuse. Here opposite is FT, hypotenuse is where FQ. So this one. Okay, so this is going to be the hypotenuse. Similarly, if you are going for the relationship between this, okay, you can see this FT equal to, I told no, F sine theta plus phi equal to FT divided by FQ. So FT equal to FQ into sine theta plus phi. You can substitute FQ in this FP divided by cos phi into sine theta plus phi. The last one is, you can go for this one, that is okay, the relationship between this FB and FQ. So here once again you see this is the adjacent side, so that only it is cos theta plus phi. Okay, So now it is going to be cos theta plus phi equal to adjacent side FB divided by FQ. Okay, so now we are getting this FB formula, okay, which is going to be here, this point. Okay, we derived all the formulas. So what are the forces acting on the reciprocating parts of an IC engine? We are neglecting the weight of the connecting rod. That is very important assumption. So FP, F1, this FP is get traveled along the connecting rod, so FQ, then FQ is traveled along the crankshaft as FB, then we are getting the last one important force, that is FT. Due to because of FT only we are getting the torque. So this FB is nothing but the force acting on the crankshaft bearings. So this is the bearings, so the shaft, crankshaft, which is connected at the ends of the bearings. Okay. So these are all the formula list what we derived. So next piston effort has to be calculated based on net load on the piston plus or minus inertia force. If frictional resistance is given, it is to be subtracted. Second, force acting on the connecting rod. Third, thrust on the sides of the cylinder wall. Then fourth, crank pin effort, Ft equal to Fq into sin theta plus phi. Then Fb, the thrust acting on the crankshaft bearing. At last, we are calculating torque or crank effort. Using torque, we can calculate how much power is generated by in the IC engines, given IC engine. So the next one problem we will do it. So with that, we will finish this video lecture. The next video lecture, we will do some other practical problems. So the first problem we are looking in this dynamic force analysis on the IC engine is the crank pin circle radius of a horizontal engine. Here they give an horizontal engine, which is crank pin circle radius means what? It is nothing but the crank radius. Okay, so the crank radius is given. Crank radius is given. Okay, the mass of IC engine is going to be given as 250 kg. So that is M. When the crank has traveled 60 degrees from the inner dead center, the difference between driving and back pressure is 0.35 Newton per mm square. That is, they are giving directly what is the net difference in pressure for left hand or right hand pressure, otherwise driving and back pressure, whatever it is, the difference in pressure is 0.35 Newton per mm square. Okay, so the connecting rod length is 1.2 meter. Then cylinder bore diameter is 0.5 meter. Speed of the IC engine, the engine running is 250 rpm. So you can calculate 2 pi n by 60. So omega. So what is the net load on the piston? So the net load on the piston is P1 minus P2 into pi by 4 d square. So if you are substituting 0.35 and diameter, since pressure also in mm, diameter you can substitute in mm, so you can get the answer in terms of Newton directly, 68,730 Newton. Otherwise you can also write it as 68.7 kilonewton. Okay. Accordingly, in this problem, we are going to calculate the torque, is it not? So for calculating the torque, which is produced by the IC engine, we need Ft. Okay, so R is crank radius. If I need Ft, then I have to calculate Fq. Okay, so if I need Fq, then I have to calculate Fp. So that is the reverse thing. Initially, it is nothing but, so the net piston effort Fp is going to be transferred to connecting rod, then it is transferred to crank. So we are calculating this. In order to calculate the Fp, we are going to calculate two forces, Fl minus inertia force. Okay, so the next slide we are going to calculate the inertia force. So in order to calculate the inertia force, okay, we need N. N is nothing but the length of the connecting rod divided by crank. So 1.2 divided by 0.3 is coming as 4. So the formula for that is mass of the reciprocating parts into omega r cos theta plus cos 2 theta by n. So you can substitute the given data, mass, omega and theta. We are getting the inertia forces 19 kilonewton. Okay, what is the next piston effort? It is nothing but the load FL minus FI. We calculated both. So it is 68 kilonewton minus 19 kilonewton. We are getting the 49.4 kilonewton. So the next one what we are going to calculate is the force acting on the cylinder walls and force acting on the connecting rod. So for that I need pi. Okay, angle of inclination of the connecting rod to the line of stroke. So sin phi equal to sin theta by n, where theta is 60 degree, which is given. N equal to 4. Substituting this, we are getting phi equal to 12.5. So now, what is the pressure on the slide bars? It is nothing but the F1 Fp into tan phi. Substitute the Fp what we calculated just now. We are getting the 10.96 kilonewton. The next force is force acting on the connecting rod, which is nothing but the Fq. Okay, since it is the axially on the connecting rod, we are calling it as thrust. Okay, force as is axially it is happening, so we are calling it as thrust. So Fq equal to Fp divided by cos pi. If I am substituting Fp and cos pi, I am getting 15.62 kilonewton. Then the last important thing is we are calculating the tangential force on the crank pin, which is nothing but Ft equal to Fq. Just now we calculated into sin theta plus phi. If we are substituting this value, we are getting the main important, the crank pin effort as 48.28 kilonewton. The last, the very important one we are calculating is turning moment on the crankshaft, that is Ft into R. So we substitute 48.28, then the radius of the the main important torque value is 14.48 kilonewton per meter. So thank you for this video. Let me go for the next problems. Okay, otherwise the practical problems we solve it in the next video.